Welcome to YQ Academy, REST API, Interview Questions and Answers. 1. What is statelessness in RESTful web services? As per REST architecture, a RESTful web service should not keep a client state on server. This restriction is called statelessness. It is responsibility of the client to pass its context to server, and then server can store this context to process client's further request. For example, session maintained by server is identified by session identifier passed by the client. 2. What is the difference between monolithic, SOA, and microservices architecture? Monolithic architecture is similar to a big container wherein all the software components of an application are assembled together and tightly packaged. A service-oriented architecture is a collection of services which communicate with each other. The communication can involve either simple data parsing, or it could involve two or more services coordinating some activity. Microservice architecture is an architectural style that structures an application as a collection of small autonomous services, modeled around a business domain. 3. What is the purpose of HTTP status code? HTTP status code are standard codes and refers to predefined status of task done at server. For example, HTTP status 404 states that requested resource is not present on server. Consider following status codes. 1. 200, OK, shows success. 2. 201, created, when a resource is successful created using POST or PUT request. Return link to newly created resource using location header. 3. 304, not modified, used to reduce network bandwidth usage in case of conditional GET requests. Response body should be empty. Headers should have date, location, etc. 4. 400, bad request, states that invalid input is provided, e.g., validation error, missing data. 5. 401, forbidden, states that user is not having access to method being used, for example, delete access without admin rights. 6. 404, not found, states that method is not available. 7. 409, conflict, states conflict situation while executing the method, for example, adding duplicate entry. 8. 500, internal server error, states that server has thrown some exception while executing the method. 4. What is the use of accept and content type headers in HTTP request? Accept headers tells web service what kind of response client is accepting. So if a web service is capable of sending response in XML and JSON format, and client sends accept header as application/XML, then XML response will be sent. For accept header application/JSON, server will send the JSON response. Content type header is used to tell server what is the format of data being sent in the request. If content type header is application/XML, then server will try to parse it as XML data. This header is useful in HTTP POST and PUT requests. 5. Whether do you find GraphQL the right fit for designing microservice architecture? GraphQL and microservices are a perfect fit, because GraphQL hides the fact that you have a microservice architecture from the clients. From a backend perspective, you want to split everything into microservices, but from a front-end perspective, you would like all your data to come from a single API. Using GraphQL is the best way I know of that lets you do both. It lets you split up your backend into microservices, while still providing a single API to all your application and allowing joins across data from different services. 6. Explain what is the API gateway pattern. An API gateway is a server that is the single entry point into the system. It is similar to the facade pattern from object-oriented design. The API gateway encapsulates the internal system architecture and provides an API that is tailored to each client. It might have other responsibilities such as authentication, monitoring, load balancing, caching, request shaping and management, and static response handling. A major benefit of using an API gateway is that it encapsulates the internal structure of the application. Rather than having to invoke specific services, clients simply talk to the gateway. 7. What are the advantages of statelessness in RESTful web services? Web services can treat each method request independently. Web services need not to maintain clients' previous interactions. It simplifies application design. As HTTP is itself a statelessness protocol, RESTful web services work seamlessly with HTTP protocol. 8. What do you mean by idempotent operation? Idempotent operations means their result will always same no matter how many times these operations are invoked. 9. What should be the purpose of options method of RESTful web services? It should list down the supported operations in a web service and should be read only. 10. Enlist some important constraints for RESTful web services. RESTful web services follow a set of constraints to ensure the architectural principles are upheld and that the services are designed in a scalable and interoperable manner. Here are some important constraints for RESTful web services. 1. Client-server architecture. The client and server are separate entities with distinct responsibilities. The client is responsible for the user interface and user experience, while the server is responsible for data storage, processing, and management. 2. Statelessness. Each request from a client to the server must contain all the information necessary for the server to fulfill the request. The server should not store any client context between requests. This constraint improves scalability and simplifies the design. 3. Cacheability. Responses from the server can be cached by clients or intermediate servers' proxies to improve performance and reduce the need for repetitive requests to the server. 4. Uniform interface. This constraint defines a uniform set of operations HTTP methods that can be applied to resources. The uniform interface includes identification of resources using URIs, manipulation of resources through representations e.g., JSON, XML, self-descriptive messages that include enough information for the recipient to understand and process the request/response. Hypermedia as the engine of application state HTTP, which means that clients can navigate the application's functionality through hyperlinks embedded in responses. 5. Layered system. Intermediary servers, proxies, gateways, etc. can be inserted between the client and the server without affecting their interaction. Each layer can provide certain functions, e.g., load balancing, caching, while remaining transparent to the other layers. 6. Code on demand optional. This constraint allows the server to extend the functionality of a client by transferring executable code. However, this constraint is optional in REST and is not commonly used in most scenarios. 11. Name some best practices for better RESTful API design. 1. Use descriptive resource names URLs. Choose clear and meaningful resource names in your URLs. This makes the API endpoints more intuitive and easier to understand. For example, /users is more descriptive than /u. 2. Version your API. Include the version number in the URL to maintain backward compatibility as your API evolves. For example, /v1/users can represent the first version of the user's resource. 3. Use plural nouns. Use plural nouns for resource names to maintain consistency and improve readability. For example, /users instead of /user. 4. Nesting resources sparingly. Limit the depth of resource nesting to avoid overly complex URLs. Consider using subresources for relationships that make sense, but don't overcomplicate the structure. 5. Use pagination. For resource collections that can potentially be large, implement pagination to retrieve results in manageable chunks. Use query parameters like page and limit. 6. Consistent error handling. Design a consistent error handling approach that provides meaningful error codes and messages. Include a standard format for error responses. 12. What should be the purpose of head method of RESTful web services? 1. Resource availability check. The head method is often used to check whether a resource exists or is available on the server without incurring the overhead of downloading the entire resource representation. This can be helpful when determining if a certain resource URL is valid before making a subsequent GET request. 2. Header information. Sometimes, you might need to retrieve only the headers of a response to gather information such as the content type, last modified timestamp, or e-tag for caching purposes. 3. Caching and optimizing requests. The head method can be used to determine whether a cached copy of a resource is still valid by checking the e-tag or last modified timestamp before deciding whether to fetch the full representation using a GET request. This is the end of our REST API interview questions. We hope you enjoyed learning with YQ Academy. Until next time, goodbye.